Hi everyone. So this video is going to be about the signals that I have on the layout. It'll cover the type of signals that I have, the integration with JMRI, and also signal Mast logic within JMRI. So obviously JMRI needs to know about all the signals that exist on the layout. So these are set up as signal masts. I use the standard BR 2003 signal. Most of the signals, if not all of them, I think are essentially 3 aspect signals on my layout. Having said that, I do have some ground signals that are 2 aspect, and I also have signals with a theatre indicator box on the top of the signals, which are controlled separately to the signal itself. So these are the main signals that I have on the layout. They are 3 aspect signals with a theatre indicator box on the top. They're made by TrainTech, and they have the DCC decoder in the base, so it makes it really easy to link it to JMRI. And simply by setting up the signals with signal masts, it allows me to control the signals. So for example, the signal for platform 1 is number 130, so it's currently set as danger. If I change that to proceed, you'll see that the signal here has gone green, and in terms of the theatre indicator box on the top, this is just controlled by whether it's on or off. The numbers here are applied to the DCC decoder on the signal, so you actually apply number 130 to the signal, and automatically the theatre indicator box for the TrainTech signals will be 132, two above. Now, in terms of signal mask logic, you have to have a source signal and a destination signal. So for platform 1, for example, the signal 130, the destination signals will either be 501, which is a dummy signal, doesn't actually exist on the layout as a physical signal, or 500, depending on which route out of the station we are sending it. So in terms of signal mask logic, we'll have signal 130 set up to link with 500 or 501. Obviously the aspect set on these signals can change, but there's no physical signal on the layout for these, but it then has a bearing on what aspect would be shown for signal 130. Digging into the signal mask logic, if we assume that a train was going to go from platform 1 out onto the main line on the up fast, it will be the link between 130 and 501 that matters. So just as an example, in terms of what we might check for this, obviously the blocks in between the signals, the 2 signals 130 and 501, some of them have to be in a state of unoccupied, otherwise the signal should be red. The point work should be set, so these are the different points that it has to go through in order to reach that signal. I'll talk a little bit more about these sensors shortly, but they're obviously sensors that I set. But call out this one, which is signal 130, has to be active because otherwise the signal will show red. And the other 2 sensors on here are the forward and reverse sensors on a particular block or section, and I think it would be good to talk a little bit about what these mean. This I found is really useful to add on to the sensors because this determines whether a route has been set. So I know that leaving the station is considered the reverse direction. So if a train has a route set to leave the station, the reverse sensor will be set active and the forward sensor will be set inactive. In other words, a train is leaving the station. If no route is set, both of those sensors seem to be active. And I found this to be a really helpful way to determine whether JMRI has set a route for the train in dispatcher. And obviously, if a route hasn't been set, then I tend to not change the signal to green. A little bit more about where those sensors are set. So you need to set up an internal sensor to begin with. So I just named them after the block. So I think the example we were looking at was down fast with up slow, forward. So that's these two here. I just set those as internal sensors. They're currently set to unknown at the moment because I haven't run any trains. And then within the sections, there is the ability here to set up direction sensors. Now they are optional and I didn't know what they were originally, but since I was struggling with an issue of knowing whether a route had been set by dispatcher and making sure that the signal was only going green when a route had been set. So then I found that this is the way in which to resolve that. And as I say, if a train is heading into the station, then the forward sensor will be active and the reverse will be inactive. And if a train leaves the station, or sorry, a route has been set to leave the station, then the reverse sensor is active and the forward sensor is inactive. I think this is really important for you to use if you're interested in dispatcher and the feedback of has dispatcher set a route in JMRI. This is the way to do it. Now the way in which my trains respond to the signals, if I take an example, transit, so I'll look at platform 1 to up fast because that's what we were looking at previously. So if I edit that, if I have a look at what it does for section, the platform 1 section, you'll see we have these 3 lines here, which is essentially that when P1 signal hold, which is another internal sensor, is active, the train speed will be 0. Train cannot leave the station. When the signal has become active, this isn't the signal hold, but the signal becomes active, then the train can leave the station, and we use a speed of 20% for the train to leave the station. Now these internal sensors are controlled by whether the signal here has gone green, and I can also add some delays to ensure that the train does not leave as soon as the signal goes green, but there is a delay for the driver to notice that the signal has gone green and to be able to leave the station. So looking at the logic for when a signal goes green, based on the signal Mast logic, obviously the route has to be set, points have to be correct, and then there is some logic for setting internal sensors that tell the trains to leave the station. So if we have a look at platform signals, we'll have what happens when signal 130 goes green or yellow. We can set P1 signal to active, and we will do that after 6 seconds. So here is where we're adding in the delay. A train won't leave the station even though the signal's gone green for 6 seconds, and obviously we set P1 signal hold to inactive, and if the signal was red, as in there was no route set, the points weren't correct, then we will obviously set P1 signal to inactive and P1 signal hold to active, meaning that the train can't leave the station. Now, there was one other sensor on the signal Mast logic, and that was that signal 130 was active. Now that can be set by can be set manually by telling the sensor that it's time to let the train leave, or I can set it on a timer so that the signal will become active 120 seconds after a train has arrived in the station. There's obviously many different ways in which to do that and apply the logic, but essentially I wanted some control over at what point the trains would then be given a green light. Now, I thought I'd keep this video brief. Obviously there is more complex logic. For example, where a train enters into this section here, which is signal 120, it can then enter into the 5 different platforms. So there is logic that I have for how it determines which route it's going to take, and that's based on which platform is available for that train, but I can cover that in another video. I hope that gives an idea of how I have the signal Mast logic set up on my layout, and how the trains actually respond to that, respond to the signals on the layout. Thanks for watching.